Hello everybody, it's Hydro Mike and welcome back with Coding with Hydro. If you remember where we left off, we struggled trying to get just a border on our screen, just like this. Oops. And I said that we were going to now visualize this graph that I was talking about. I was talking about how we can move to ensure that our frog is A, equaling the exact edge of each screen, left and right, top and bottom, and he's moving in exactly this grid pattern. So when we go to even say draw a background, like physically draw a background, we can have in the drawing program, we can set our canvas to 608 by 608, draw this grid system over top of it, and we can literally draw our background exactly how we want it without any issues. Alright, so you will see a lot of my code is hashed out, pound out, commented out, however you want to say it. That's because I progressed a lot more, and I did do the videos during it, but the struggle bus comes in hard, and I just want to skip all that and just explain to you what I ended up coming up with. So first things first, the grid. To visualize what I did. So what I did first is I just created a grid width variable, which remember, something I just made up, and I called it frog size, right? What is frog size? Right here, frog size, remember? It's what we initially set our frog to. So I'm going to reuse it, just so if I do change my frog size, and I need to come back for whatever reason and make this grid visible again, I won't have to do as much to get this to work again. So then I made this right here, grid columns. This symbol right here is the symbol for an array. And just think of an array is an empty container right now, and I'm going to put stuff in it. What I'm going to put in there is the grid lines, right? The horizontal grid lines and the vertical grid lines. Excuse me. And in the array, it'll hold, remember how we made these lines? It's going to hold all this information per item I put into this container, right? This is just going to hold my horizontal lines, my vertical lines, and this one is going to hold all the information for my horizontal lines, right? And how are we going to get them in there? We're going to do it with a for loop. And all the for loop is, it's just me saying for I is just a variable I've made up. It means nothing. It's just a placeholder, something to count. And what are we going to count to? We're going to count to 18. That's what I chose my range to be, because I did some math. My screen is 6.0 by 8. If I want 32 pixel wide squares on my grid, I need to make 18 of them across. Well, it's actually 19, but I'm not going to count, or I'm not going to draw the first one or the last one, however you want to look at it. So, how we do that? I'm going to put M. M again, it's just a variable I'm making up. Means nothing, just a placeholder. And what I'm making M equal to is a line. By grid width, which remember we've made equal to frog size, which is 32. So it's going to be 32 by 0. This is the starting position. So it's going to start 32 pixels to the right of the left side of the screen, right? And then at 0, so all the way at the top. 32 pixels in, all the way to the top, and then grid width at all 32 pixels in, and then at the height though. So that's just the top and bottom point, and it's going to draw a line between the two at 2 pixels thick, and we're going to color it white, right? So that's what M is going to hold. So it's going to go for I, which I is going to equal, I basically just going to equal while we're counting as the numbers 0, 1, 2, 3. Every iteration of this loop equals 1, 2, 3. I is just counting for us. This is a way that we can do a loop for only a certain amount of time, and then when it's done with that loop, it jumps out and continues on. Unlike our while loop, in order to get out of that, we'd have to turn something true or false. We'd have to be conscious of how to get out of that loop. If not, we'll be in it forever. This one, it will only be in it for the count of 18, and then it hops out. So the next step is now grid columns, right? Grid columns is an array, our container. So what we're going to do is grid columns.append m. All that's saying is, okay, what I want you to do, create a line, and then I want you to append it into grid columns, right? It's just grid columns.append m. So we're taking m, which is a line, and putting it in there. That's all we're doing, right? And then it's grid width plus equals 32. I'm just telling it now that it did this one, and it's going to go back and do the next number, or so we just did 1, right? Now it's going to be 2. It's going to go through the exact same thing again that we just did, except for I plus grid width 32 pixels. So now instead of grid width being equal to 32 on this time around, it's equal to 64, which moves that line 32 more pixels to the right to draw our next one. So it does the same thing. Makes a line. We put the new line in the second position of our array. Then we move the grid again. And we move the grid width variable another 32 pixels. And we do that 18 times. So now we're going to have 18 lines, all the information to draw 18 lines inside this grid columns. And we're going to do the exact same thing for the grid row. It's literally the exact same thing, except for instead of the horizontal lines, we're going to do the vertical lines. So it's going to start at 0, grid width, which is 32 pixels down this time, to the width, 32 pixels down. So, and then we're just going to go down and make 18 lines down, right? So that creates the lines, right? So now we have them stored in here. So now we have to draw them. And I have the horizontal lines green, so easier to see. So now we just have to go down here. And how we're going to draw them is almost kind of the same idea as how we created them. For I, again, I is the placeholder, but instead of like range 18 I had up there, it's going to be in grid columns, right? Grid columns has a certain amount, 18 of them that are in there, right? So it's going to count 18 because that's all that's in there. It's going to go start at 1 and go all the way to 18. In every iteration, it's going to be, okay, first one of grid columns, okay, I dot draw. I is taking the place of our line M up in the other one. So I in grid columns, okay, I dot draw, okay, next one, draw, next one, draw, next it's going to do it 18 times, or however many we put in there, it's going to do all of them, and then it's going to pop out, and we go to the next one, same exact thing, except this is the rows, and there you go. That's it. We should have our grid now on the screen. There you go. Let me go to our other view. And holy cow, I struggled on it so hard to get this on there, trying to figure out the for loops. I kept screwing it up. Again, like always, I got the X and Y screwed up in my head when I was trying to do it. I forgot about my grid width variable, so it did all my vertical lines, and then I forgot to set it back to 32, so when it was starting the horizontal lines, it equaled like 600 something. I wasn't realizing it, so I was drawing my horizontal lines, but I was drawing them way off the screen at the bottom, and I couldn't figure out what's going on. But I digress. Here we have our frog, right? Well, I wish you guys could see that I always forget to click back on the game here. Alright, there's our grid. He is moving exactly 32 pixels every time you hit the up button. Left, right, up, down. In exactly this grid, right? And when he's here, he equals exactly here. He can't go any further, and he equals exactly. Both sides, top and bottom. And there, so now you can visualize what I was talking about when it came to the grid. Yeah, so that's it as far as the grid is concerned. And sadly, this is the only reason I drew it. And it took me like 2 hours to get to this point after we created our original border lines. But it's a lot clearer to me now. I learned a lot doing it. And so our next step now, after we draw this grid, is to A, comment out the grid, because we don't need it while our game's running, but I want this for informational purposes only. Like if we decide to make the screen bigger or things like that, it'll help me figure out how much I may need to make the frog bigger or a car bigger or something to that extent. So there we go. That is the grid. So let's comment out the grid again. Grid is all commented out. Okay, so now you can see this whole mess of commented out text. So we actually made a one car. Well, I think I cut this part of the video out because I'm redoing it now. I got to a point where I had one car and I could move that car, and moving that car, I decided that I wanted to actually break down and make a class for my cars as well. So we have our original square class with our frog information here on how to move, right? So my car class is exactly the same, except for I was trying, in my head I was trying to figure out how to do the collision detection, which is going to have to happen eventually. So I decided just to make a new class and see how it went. Well, it wasn't going so well. So then I did some reading up, and then I turned my square class into a sprite class as well. So it's still a class, but it's technically a sprite class. Right, I did that for my car and my frog. And the change is nothing when it comes to creating a class. It's just a sprite class has some other built-in functions that we can use that I actually didn't know about until, we can use for collision detection, right? It has a built-in function called if this group of sprites collides with any of these other sprites, you can actually just make it instantly disappear. Like there's a lot of other things, but I'm not good with it, so I did it the hard way. Or I didn't do it the hard way. I love how I did it, but we'll get there. Okay, so we have another car class, right? I am again going to pass in width and height of the size of the car, the X and Y, the starting locations of the car, the color, the distance, and speed. All right, so speed and distance. We won't get to this yet. So I have my car X, my car Y, right? Those are the variables that I'm going to pass in for my car's locations. Alright, so the first thing I created, since they're sprite groups now, I went car row equals a sprite group. And just like how on the columns I had an array that I was making a line, put it inside the array, make a line, put it inside the array. I'm going to do that exact same thing with my car squares now, except instead of an array, it's a group. It's a sprite group. So we're just going to do row 1 of cars for now. As you can see, I eventually settled on 5 rows of cars. Actually, you know what? We'll do them all. It doesn't. I mean, they're all exactly the same, and I'll walk through it. So here we go. We have a sprite group for each row of cars, and even this spot coming up, I'm going to change a little bit because I want more control over variables like the speed of the cars and how many cars are in a row. But okay, so we did another for loop just like we did when it came to the grid lines, remember? So for I is just a placeholder. It's going to count in a range. And now I used a method here called random range. And all that is, it's just going to give me a random number between 14 and 18 every time this gets run. So when you first start the game, it's going to run once and that's it. But that's going to set the amount of cars basically that I have in my traffic. Let's just call it traffic. So this really only the way I have it now will only limit how many cars are in the last row, and I'll show you why. But so for I, and whatever number this spits out between 14 and 18, I'm going to say if I is less than 2, right? That's literally all I'm going to say. If I is less or equal than 2, actually, I want you to, just like the lanes, or the lines, M equals a car, all my information for a car. And then I want you to, what? Add it to my row 1 group, right? And then plus -60 on top of my variable car X, right? What that does, my car X started at 300, right? So this is my first row of cars. It's the first car is going to get drawn at 300, right? Because it makes it this first car first. Then it makes the next car, and it just makes it 160 pixels behind it. That's all I'm saying. So that gives me the length of my car, which is 64, plus another 64 pixels, and then my car, basically, to the ass end of my next car, right? So that's all it's doing, and it's going to do that for the first 3 cars. Starts at 0, if I'm not mistaken, right? And so there'll be 3 cars in my first row, right? So now, here, I'm just saying for when I mean, we're still counting right here. It's just going to do this for the first 3, and then it's going to do this one, then it's going to do this one, then it's going to do this one. Is how it's going to work here. So if I is greater than or equal to 3, and I is less than or equal to 6, so I only want 3 of these guys to drop in here. Well, actually it's 4, but you'll see. But I have to do this extra statement saying if I equals 3, right, I need car X to be equal to 0 again, right? Or not again, but I need car X equal to 0 because I'm going to the next row of cars. I don't want it to be however many, this will be -160, -160, -160 on this car X every time. If I do that, I'll be drawing my cars way off the screen. When I get to the next row, I need to reset where I want my next row of cars to start getting drawn at on the x-axis, or x-axis. Yeah, x coordinates. So how far left or right? So right now it's at 0, right? So it's all the way to the left. I'm going to draw my first car on my second row. Its height is going to be -80. So up from the bottom, 80 pixels. Going to create my car and whatever I want. It's going to add it now to my car row 2 group. And plus 160. It's going to do this 3, 4, 5, 6, and then jump out and then do this one, right? Because this is still it's still all inside this 4 range of I and between whatever number this spits out, you know. So next row, this one is same idea. I is greater than 7, or greater than or equal to 7, and I is less than 9, less than or equal to 9. And the next one is, but when I is 7, I want you to set the car equal to width, right? Width is all the way to the right. And then I'm going to draw my cars backwards. They're back this way for my next row. Right, I'm trying to, first row draws them this way, next row draws them this way, next row draws them this way, just so they all start on the screen. And my car height now is 112. That makes it the next row up, the spacing. You'll see why I chose the number with the spacings when you see it. Again, M creates my car. Car 3 now gets these ones added to it, the group. And then 160 up, or negative 160, and boom. 7, 8, 9. Okay, oop, out now. Now we're at 10. Same deal. Right, it's exact same deal, except it's going to be between 10 and 12. I'm setting my car X back to 0. Remember, that's where I'm drawing it on the X-axis, whether it's fully left, fully right. And then now if it's just greater than 13, and if it is 13, make the car X equal to width. And there you go. So what we did here is we made a variable to hold the information for our car X, which is just where we want it to start drawing on the screen from between left and right side of the screen. Car height is, or car Y is our height, how high or low we want our car row to start drawing at. Car row 1 through 5 is just individual sprite groups holding the information of our cars in each row. In this large 4i loop is just me saying, okay, I want the first 3 to be in row 1, and when they are done, now go move on to our row 3 or our next row. And how it's knowing what row is just simply by where I'm drawing it, right? My car Y right here, I'm changing to negative 80, so it's going to go up negative 80 pixels from the bottom of the screen, basically, right? So this doesn't necessarily know what row they're making it. I'm just changing the Y the Y variable value every time it goes through this new section, and then I'm adding it to the appropriate group. Therefore, let's say if I want to do something with group 4 only or row 4 only, I can just mess with that group. I don't have to have them all in one group and then figure out how I want the third car in the second group or in the second row and figure out how to manipulate it. This way I can deal with the groups or the rows of vehicles independently if I want to. I don't know if I'm going to have to or not, but I do want to change these to their own individual for loops though. Why? So I can do something like this at the beginning of each row. And therefore I can put a nice random number. So each row, each time we play the game, the rows will have a different amount of cars in them. And before, when I said this only controls how many cars are in the last row, because these ones are all, this one's going to get 3, this one's going to get 4, this one's going to get 3, this one's going to get 3, and then the last row is the only one that's going to be basically limited, because this one's only getting whatever 13 and above 13. So this literally only limits the last row of cars. But that's okay for now. So now, just like any other thing, especially like with these lines, I always forgot to update, but the same deal. Now I just update the rows, right? I made them individual rows. I just update the rows, and we should now have cars. Bold statement, right? There we go. Now, yes, I took out all the struggle that I had. This didn't happen real quick. This took several hours for me to get. And if you notice, we started with our cars at 32 pixels thick as well, just like our frog. But if you notice now, there is a gap between our frog and the car. Because after I drew my first row, I realized if if they are that close, there's a chance that they're touching, and I will always have contact, no matter what, right at the beginning. So I didn't want to. I didn't want that. And I didn't want to have to deal with that if that was the case, and I got too far down the road to fix it. So my cars now are only being drawn at 26 pixels, right? My frog is 32. These guys are 26, and that just gives a nice little space between each row. And so when my frog is in this first row, he will also, he won't touch the second row. And while he's down here, he's not touching the first row. Just a little extra buffer room. I would move my frog, but I'll show you what I incorporated to help me with the next section. Okay. So, now in my update of my car, right? I made my own individual car group, or sprite group. I said, this update, just like any other update, assuming that you're telling it to update, runs every frame of the loop, right? So every time this loop runs, this little tiny loop that we made from the beginning, every time that runs, and it's going to run how many times? FPS, when I set it at 30, I think, right? FPS. Oh, it's running at 32 frames a second, okay. Whatever. Which, when I think about it, it's not that big of a deal. This probably works out perfect. So it's flickering, my screen is up refreshing. Probably about the proper, what it should be. But we'll see. Those are all things we can tweak. By making them variables, we can tweak them. By making them variables, we can tweak them at any time, right? And as long as we stay true to our variables and use them whenever we can. Like this, I probably should have said width divided by 2. And these should have been car size or whatever. I don't even think I made a car size. But I should be using variables as much as possible. Because if I do change any settings in the game, everything would scale properly. But I digress. Here we go. Okay, so here, this is going to process every loop. And what is it? Well, you can see this self C equals white, right? That's the color I set when I made the cars, right? So they're white no matter what. But at the beginning of this loop, I'm setting them white again, and you'll see why. What I'm saying here, if it's saying self, right, I'm referring to the car, because we're in the car class. If the car's rect X, which is the car's top left corner, so if it's hard to explain. The top left, you got a stationary, if we got a car that's stationary in the screen, right? The top left corner of it is its X. Plus 64, right? So the top left corner of it, plus 64 pixels across, which would take it to its top right corner. If that is less than or equal to the frog's top left corner, and so the and means both of these have to be true for it to go into the next section. So the top right corner of our car is greater than the top left corner of our frog, and the car's top left corner is less than or equal to the frog's top left corner plus 32. So technically I'm saying the right top corner of the frog. Sounds confusing, but I literally, at one point, I was writing it down. I was visually drawing a square and then marking where the X would be on it, and then plus 64 drawing a line. And I literally did it by pictures, right? Because I was confusing. I get so confused when it comes to X and Y, and I don't know why. I understand how it works. It just blows my mind sometimes. So if all that is true, it then goes into if the car's rect Y, which the Y is the left, is how high or low, of the Y, remember, is the vertical position of our, in this case, the car, -8. So if it is not quite the middle of our car, or the bottom of our car, right? Because I don't want the frog to inadvertently, when it gets close to it, act as a collision, right? So it's just inside the car a little bit, right? Which shouldn't be a problem, because remember, my car or my frog will be moving 32 pixels at a time. So there's no time where I'm going to be able to inch so close where I can appear to be in the car but not detect a collision, because my frog will moves way more than 8 pixels at a time, right? So, long-winded. If my car's vertical position -8 is less than or equal to my frog's vertical position, and the top of my car is greater than or equal to the top of my frog, right? If the car's top is greater than or equal to the top of my frog, right? See, this is one where I would get confused. I'm like, wait a minute, it shouldn't be greater than. But it is. The top of the car. Remember, down is greater. This stuff always confuses me. Down is greater. So when the car's top is, basically I'm saying, when the car's top is less than the top of the frog, right? Because this is greater on the screen. Going down is greater. If all that's true, turn my car red, right? And why I'm doing that is so I can visually see if it collides. And that's why I turn it white at the beginning of each thing. Because if it does turn red, the next loop around I want it to turn white again and then do this again. If I didn't turn it back white here each time, once it turned red, it would just stay red permanently, right? So, and self.c refers to all the cars. It just repaints all the cars white again. Now, here you already saw, I think, maybe you didn't, but we'll go over it because I might have cut it out since I'm doing these videos over again. This is how our cars are moving, right? Or no, this was the boundary of our cars. And I'm pretty sure, no, maybe I didn't. This is just saying if the car's left is greater than or equal to the width of the screen. So if the ass end of my car is greater than or equal to the edge of the right edge of the screen, and the right side of my car is greater than the width. So basically when it's saying my car is completely off the screen, pretty much, make its right side, right? So if it's going this way, make its right side equal to 0, which would take it, snap it all the way back to the other side of the screen, right? And then it's going to say else if my rectangle's right is, the right side of my rectangle is equal to 0, right? So if the right side of it's equal to 0 and the left is less than 0, so if the left side is off the screen, snap it to width, which would snap it all the way to the other side. Right? So, in theory, what I did is if it goes off this screen, it automatically snaps to the other side of the screen and gets drawn over here. And if it goes off this side, it snaps to the other side and gets drawn over on the other side again. In here, this direction equals 1, direction equals 2. Remember, I passed in a direction and a speed. So when we make a car, the direction I put 1 or -1. And this is just how I decided to choose whether it was going left or right. Up here I said if I passed in 1, then the center X of my car will be just plus the speed. And the speed is is the last variable I passed in. So 2. It'll move 2 pixels every frame. Right? And I don't have it, like there's no buttons tied to this, right? Oops, too far. Nope, not enough. There's no buttons tied to this, right? Right, there's nothing here saying hit right arrow key or whatever, then move it. No, this is going to happen every frame. Every frame it's going to move 2 pixels. Same with this. If I pick -1, just means it's moving the other way. And then I minus speed, so it actually, whatever speed I put in, it's, if I put in -2, or if I put in 2 for the speed, this just means it's going to be -2, right? So it goes all the way across the screen. And then draw them. And that's our cars. So again, if we look at it, I have my frog, and if my collision's working, the car should turn red. And if I'm not in, see, if I'm not in a car, so when a car turns red, I'm colliding, meaning I just got run over, right? And it will work with every car. See, this is what I didn't like about how I said the last row of cars is the only one where the randomness takes effect. There's only one car in the last row. There's no point in that. I can wait here all day and not get hit by that freaking car. So I need to control it more. But to prove that point, let's run it again. There we go. Now I got 3 cars. I know it looks like 4, but it's actually 3. You can see that bigger gap. That just means that it's that the 3 drawn in the last gap just happens to be the leftover space that's in that row before the cars get drawn again. So yeah, this is officially where I'm at. I have collision detection. I have a little safety zone here between my next row of cars. All my cars collide properly, as far as I can tell, from the front of them and the butthole, the butt of them. And my little safety zone down here doesn't collide with anything. So my next goal is I'm going to have 2 spots of safety up here. And then right here will officially be where I think the logs will start. We'll do 3 or 4 row of logs. And then our goal, we'll work on what our goal is, I think. I don't know, maybe I'll come up with something else that it can jump across or do something. And then we'll get all that. So basically, when it comes to logs, my idea is, instead of, same deal, like I'm turning red, right? But I was thinking in my head, if I don't turn them red, just think that these are the logs right now. But instead of turning them red at this moment, I can just make it equal to the speed, right? So if this speed is 2, if I jump on it, at the moment that it would turn red, it also turns my frog's speed to 2, right? So then it would move with it like this, and then the old frogger would fall in the water. So I can have anytime up here, if I'm above this certain line and I'm not on a log, so I'm not making collision, then I'm dead. Like completely, like the same exact idea as down here, but drawn, or the concept just flipped on its end. I need to be on top of one or getting squished by one. You know what I'm saying? Instead of avoiding them. So it's the same exact idea, just opposite. And I've been wondering myself if I can even make it through this. Let's see. Oh, nope, dead frog. I guess it is a game of waiting, right? There you go. You can make it. You just got to pay attention. You can't just jump up in there real quick. But anyway, that's what I have so far. And I hope you come back to see what I get to next. These are how my videos are going to be from now on. I'm not going to struggle busting through them. I'm going to get to a point that I'm happy with and then explain what I did. And hopefully that turns out better. But until then, I'm Hydro Mike. You've been watching Hydro Coding. Have a wonderful day.